Hi there. Today we're gonna go over with Unit 5 test review, and we have a test this week, so I need to go over with some of the question based on your test review. Again, we're gonna use Desmos here, so pay attention with me. The code will be given to you in the future. Okay. Now for the formulas, remember this: sum of the item negative 16t squared will be used when we're talking about feet. Negative 4.9 will be used if we're talking about meters here. When we're working on the prices here, sometimes it increases the quantity and the decrease of the price. And there are times that we have to decrease the quantity and the price increases. Likewise with the area, length times width. So let's keep going on here now. Question number one. Brianna is flying in an airplane that is 5,280 feet in the air. She throws a glue stick up in the air with an initial velocity of 42 feet per second. First, we know it's in terms of feet, so we're going to use the negative 16 formula, right? This will be negative 16 x squared. What else? It's negative 16x squared. What else? I don't know. That's not the question. The question is, what's the initial velocity? Is 42 feet per second. That's the velocity there. Okay. Next, what is the initial height? It's starting from 5,280 feet. Don't forget your unit. Okay. Next, write an equation. So where do I write the equation here? There you go. The equation is negative 16 x squared. The next one is the initial velocity. Since we're going upward, it's going to be plus 42 x. And then what's next? What's the initial height? Plus 5,280. And there you go. That's the equation there. Okay. When we try to graph, let me try to copy this one here. You might ask me to graph it. There you go. Copy your answer from the last problem. So I'm gonna copy it here. It doesn't give me anything. So h of x. There you go. It may be too big, so I have to minimize it. Okay. Then zoom the right correctly to the right. So what I can do to see the entire graph here, I have to get rid of this. Maybe I need to make the y value. Let me make it smaller further. Okay. I can maybe check the question first. What's the maximum height of the glue stick? Since I'm looking for the maximum height, I need to find the highest point of the graph, right? So I have to scroll up there. But since it's too high, I might need to make the zoom of the y value big enough, like maybe 6,000. There you go. There you go. I can see the maximum height, and the maximum height here is, there you go, 1.3. So I need to write that down, 1.3 and 5307. 1.3, 5307. What's the meaning of that one? The meaning of that one, at 1.3 seconds, the graph or the glue stick went 5,307 feet high. So answering the question here, what's the maximum height? Is 5307 feet. And then when does the glue stick hit its maximum height? At 1.3 seconds. How long does it take the glue stick to hit the ground? So I need to go back here and see the x value, the x-intercept. There you go. Can you see that one? It says there 19.526 comma 0. So in 19.5 seconds, it hits the ground. So this will be 19.5 seconds. How high is the glue sticks after 3.5 seconds? So the best thing to do that one is type in here h of 3.5. Why h? Because I label here as h, and you can see the answer from right here is 5,231 feet. 5,231 feet. Okay. The next one here. All right. This is question number 2 now. Laura throws an apple from the ground. So she started on the zero on the ground, up in the air. So the velocity is going up. So it's positive. What's the initial velocity here? So it's going to be 60 mpс, meter per seconds. What's her initial height? It's going to be 0 meters because she's in the ground. Laura throws an apple from the ground up in the air with 60. Write the equation. So since this is meters, negative 4.9 x squared. Again, you can use t squared, but I'm more familiar with x, and that's wrong. Erase everything. X squared. Since the velocity is 60 x, starting from ground, you can put plus 0, or you don't have to. I don't really have to, so I can keep it that way because she's starting from the ground. All right, so copy it. I'm gonna put here h of x is equal to, copy the equation from the previous screen, and then I need to find what? What do I need here? What's the maximum height of the apple? Okay, so I need to move it on the side here, minimize it, and the answer is right there, which is 6.1 at 183. 6.1 at 183. What was it again? 183. There you go. That's good enough. All right. And then go to the next problem. So what's the maximum height? The maximum height is 183 meters. When does it happen? When does it happen? At 6.1 seconds. 6.1 seconds. How long does it take the apple to hit the ground? So we go back right here and find the x-intercept here. It says there 12.2 comma 0. So in 12.2 seconds, the apple hit the ground. So 12.2. And what's next? How high is the apple after 5 seconds? So what we do, we go here and then type in h of 5 because that's 5 seconds. The answer will tell you over here is 177.5 meters. Oh, it's a different one. 177.5 meters. There you have it. Okay. Question number 3. The cafeteria charges $4 for a small pizza. They currently sell 3,000 pizza per month. They have decided to increase the price. They have found that for each 25 cents increase, they will sell 250 less pizzas. What was the original price of pizza? What's the original price? It's $4. What were the original sales per month? The original sales per month is 3,000. They're selling 3,000 of pizza every month. And will the price increase or decrease? As they have found that for 25 cents increase, so it has to be increased there. With the sales increase, all right, it says there the sale will decrease. So I'm gonna hit the decrease portion here. What write the equation? So since we are selling $4 there, that's the price, and 3,000 is the sales. Okay, so this the first one is the price. There will be an increase of 0.25 cents x, and there will be 250x less every time there's an increase of price. So submit that one. I'm gonna copy this, and my time is running out here. So I would like you to graph this one now and see what happened. Okay, I'll continue in the next video. Kaboom!